Hi everyone, so in this video we will look at a real world example, and that is we have to design a workflow for a banker, right? So in this question you're given there is a bank which is open till 6 p.m. and banker needs to process the four type of requests. These requests are of cash deposit, cash withdrawal, check deposit, and making a demand draft, right? So you need to design a workflow for the banker, right? So again, it's a real world problem. So let's think how we can design a workflow, right? So the banker will start once the bank is open. So his job starts when the bank is open. So you have a start box. So it denotes your bank is open. So your job is now started. And now you have to think till what time he's going to work, right? So that is clearly given in the question that the bank is open till 6 p.m, right? So it's given it's open till 6 p.m, so we can use this and we can put a decision box, right? That will basically help the bank manager to think if he wants to work or not, right? So also there is another condition, right? So if the bank timings have been closed, if the bank but there are people in the queue and it's after 6 p.m, then the banker cannot go home, right? Because all those customers who have entered the bank before 6 p.m and they are in the queue, they have to be served first, right, before closing the bank, right? So you can put a box like this: is queue empty? If there are no people in the queue and your time is greater than 6 p.m, right, only then you can close the bank, right? If this is the case, okay, in that case, if this is the case, you can close the bank, right? So the simplest case, the bank will close only when there are no customers and time is greater than 6 p.m. So you close the bank, that's it. But the little more challenging part is when you have customers in the queue, right? So it means you have certain people who are standing in the queue, you have to serve those customers, right? So again, you have to check if there are people in the queue, then you will do some work, right? So is queue empty or not? Is queue empty? If it is not, okay, if it is not, okay, and then you have to handle the customer requests. But suppose the queue is empty, right? Then what you will do, you will wait for 6 p.m, right? Okay, you will wait for more customers or you will wait for 6 p.m, right? So we will go back to this point, okay? But if the queue is not empty, right, if the queue is not empty, you have to serve the customers. So you remove a customer from the queue, remove the customer from queue. And removing customer from the queue is a part of processing. You're not giving input output, so you're processing a customer request, so it goes in a rectangular box. And once you have the customer ready, you will ask what kind of request it is it of type 1, 3 or 4? So a customer can make one of these requests, so you will read the request from the customer. So this is going to have a input box because you're reading the type of request. Now this request can be of multiple types, right? So we can check if the request is of the type demand draft, or is it check deposit or withdrawal or cash deposit. So you can check, is this request of the type demand draft? Is it a demand draft request? Okay, or is this request of type 1? If this is the case, right, then we will have a separate flow which denotes how to handle a demand draft request. If this request is of cash deposit, if it is not DD but it is cash deposit, you can say okay, cash deposit. If the customer wants to deposit some cash, you will have a certain flow which starts from B, and that will handle how to deposit the cash. Okay. And if it is not the case, you can ask what is the third option. Is this request for cash withdrawal? Okay, so if that is the case, you will have another flow that is going to handle how to withdraw cash. If it is not the case, if it is the final case, that is cash deposit. Okay, okay. Or yeah, so it is check deposit, and here we have cash deposit. Okay. So if that is the case, you have another flow that manages how to deposit the cash. If it is not the case, maybe you have something else, right? Maybe you have some other kind of a query. Okay. And once you are done by finishing all of these requests A, B, C, D and E, you will again check if the queue is empty and time is greater than 6 p.m. or not. So what we can do, we can combine the outputs from A, B, C, D back into this. Okay. So you put arrows here just to denote how you're going to flow. Okay, or we can just merge it into the same branch. We can say, okay, after all of these cases, we will come back to this particular point. You come here, you come here, you come here, and you come here. Okay. So this is what you are going to. And also in case of E also, you will come back here. Okay, so this denotes the entire flow, right? So this is the workflow of the banker, right? So maybe now you want to complete the other workflows also, right? You need to complete A, B, C and D. Okay, so this is for the banker, right? So as a assignment, you will have you have to complete A, B, C and D. So you can fill in the required details by yourself. So you try to make A, B, C and D. So here A, B, C, D are connectors. So you can connect multiple flowcharts into a single flowchart, right? And that's it for this video, guys. I hope you got an idea. And also here you can see the banker is in a continuous loop till his working hours are not closed, right? So he's continuously checking for more people in the queue and waiting for time is 6 p.m. or not, right? That's it. See you guys in the next part.